Hello friends, welcome to Dari Marana YouTube channel. Today we will be discussing about fuse. We all have heard about fuse and all. Let's have a basic idea and understand about the working principle and types of fuses and all. Fuse is an essential device mainly used in electrical circuits. It gives protection to the electric circuits during overcurrent. Because we all know that every electrical equipment have certain load carrying capacity, load withstanding capacity. If excess current or excess load goes through it, it will get heated up and finally it will get broken and fire will catch. So in order to protect the electrical device from this overcurrent, we use electrical fuses. Electrical fuses is mainly is a material. It consists of strip of metal wire. It allows dissolves when heavy flow of current flows through it. This this is the picture of a fuse. This inside this fuse there will be a wire. This wire is made of zinc, copper, aluminum, and all. This because and when heavy current flows through it, it will get burned out. Thus, protect the electrical circuit from overheating and all, in the effects of overcurrent and all. These are some of the symbols of the fuse in a diagram and all. Usually, we use ANSI standard type of symbols for using application of fuse for representing fuse and all. Now, the working principle of fuse is mainly based on heating effect of current. Heating effect of current means it's simple. Whenever a short circuit or overcurrent or mismatch load connection happens, then through the thin wire, heavy current flows to it, and it will get melt, and thus heat generator it will get melt, thus protecting the rest of the heavy equipment from further damage. So because the connection will be disconnected and power supply will not be completed, thus this fuse play a major role protecting the electrical equipment in case of overcurrent or short circuit. In normal operation, the fuse is just a low resistance component, so it will not carry or consume much more resistance. So voltage and all, voltage current and all. So it is actually in normal operation. We will not feel any effect. But in case in situation where current is increased, then we will understand this fuse will get heated up and it will melt. Thus, disconnecting the connection, thereby protecting the electrical equipment from in case of overcurrent and all. Here we see the picturization in two conditions. In normal operation, the condition of fuse and all. What will happen when there is a scenario of overcurrent? Overcurrent means in that scenario the fuse will get blown and thus protecting the device. And types of fuses. Fuses means here two types are there: DC fuse and AC fuse. In DC fuse, there are no sub-branches, but for an AC fuse there are two divided into two, that is high voltage fuse and low voltage fuse. In that high voltage fuse is again divided into three. They are expansion type HRC fuse, liquid type HRC fuse, cartridge fuse. In low voltage fuse it is divided into five. That means they are cartridge type low voltage fuse, dropout fuse, switch type fuse, striker type fuse, and revariable fuse. In that cartridge type low voltage fuse is again divided into two, that is link type fuse and D type fuse. In that D type fuse is again branched into blade type fuse and bolter type fuse. These types of fuse are just for our knowledge purpose, just to try to remember the name and all for the sake of knowledge purpose. Thank you.